Hello everyone, it's me again, Mr. Hui, and I'm so glad that I can teach you one more year in Math UMS class. Uh, this year I will try to make mathematics as friendly, as easy as possible. I don't want to scare you off my classes, but I hope to engage everyone, and I hope you to pay attention and get involved in the class, although this is a class in cyber school, which means we do not have the person-to-person contact, but still will try to engage you as much as possible in my lesson. Okay, and I hope that besides learning something informative, something valuable, I will also try to give the lesson as funny as possible, so that everyone can enjoy the lessons. Okay. That's my promise. I'll try to deliver it. Okay, now let's get to the lesson today, the polynomials. Can you guess the meaning of the word polynomials? Because you have learned the concept in Vietnamese math class, polynomial. Does the prefix poly sound familiar? Poly. Poly means nhiều in Vietnamese, and polynomials in Vietnamese we call it đa thức. Okay, so here I will give you the definition of polynomials or polynomial functions. A polynomial function is a function of the form, or it can be rewritten in the form. Yeah, it means that there are some expressions which are not in the form, but you can rewrite it into the form, so it is still a polynomial. The form of the form of a polynomial function is given as in the screen. Px equals a n x to n plus a n minus 1 times x to n minus 1 plus so on and plus a1x plus a0. This is called the standard form. In the standard form, please note that the powers of the x are um, arranged in the decreasing order. It gets smaller and smaller, and no two terms sharing the same power. Here I'll give you some example. 6x to the power of 3 minus 2x to the power of 2 plus 3x minus 7. This is a very normal and friendly polynomial. It has exactly the form It has the exact form of the standard form, which is given above. And here is another example of polynomial. Negative 2x to the power of 4 minus 5x to the power of 2 plus 3x minus 7. You can see that in this polynomial, the term x to the power of 3 is missing, but it's totally okay. We can miss some terms in the polynomial. We do not have to have all the powers from 0 to the power of degree n. We can skip some terms like this. It is totally fine. But this polynomial can still be written in the standard form, of course. Every polynomial can be rewritten as the standard form. You can see that because we have no x to the power of 3 term, so we add it with the we write it as 0 times x to the power of 3 to fill the blank, so that we have all the powers from 4, 3, 2, 1, and 0. And note that the terms are arranged in an order of decreasing powers, from 4 getting smaller and smaller to 1 and then 0. See? Not too difficult definition, right? In order to have a thorough understanding of something, we want to have not only examples but also counterexample. Counterexamples are the examples of something that are not of the concept. For example, these expressions are not polynomials. Here, 1 over x minus 1, 3 minus 2 divided by x to the power of 2 plus 1, and square root of 3 minus x. These are not polynomials. And now we will have a closer look at a polynomial to understand the parts of a polynomial. Okay, px equals a n xn plus a n minus 1 x n minus 1 plus and so on x a1x plus a0. The x is called the variable. In Vietnamese we call it biến. And a n minus 1 a0, you can see the numbers are colored in orange. They are called coefficients. The coefficients are nothing but the numbers that are multiplied by the variable part. They are numbers that are multiplied by the variables. And among those coefficients, there are two special coefficients. The first one is an. It is called the leading coefficient because it stands first in the line. It is the coefficient that is multiplied by x to the power of n. The term with the highest degree. And a0 here, colored in red, it is the constant term. It is called the constant term, the term that doesn't change, because it does not depend on the value of x. It is not multiplied by x, so it is not changed when we modify the value of x. That's why we call it the constant term. And finally, we have n. It's the degree of the whole polynomial. Roughly speaking, the degree of a polynomial is the highest power of all the terms in the polynomial. Now let's have a look at this example. Px equals 6x to the power of 4 minus 5x to the power of 3 plus 12x minus 4. The variable, can you do the problem with me? A variable is x, coefficient. We need to list all the coefficients in their decreasing order. First we have 6, and then move to the lower degree. We have negative 5, and then please do not miss the coefficient 0 here. It is the coefficient for the missing term, which is x to the power of 2. We do not have the x to the power of 2, so we write the coefficient of it as 0. Moving on, we have 12 is the coefficient of x, and negative 4 is the constant term. Don't forget 0 to the power of x squared. And the leading coefficient is 6 here, the coefficient that stands first in line. The constant term, the term that is not multiplied by x. In this case, it is negative 4. Degree is the highest power among all the powers. In this case, it is 4. Can you get it? Let's have another look at this example before we move to another one. Okay, now let's practice with this example here. Px equals negative 3x to the power of 5 plus 3 over 2x squared minus 4x plus 18. The variable, still the same, x. The coefficient, -3, and because we do not have the x to the power of 4, so the coefficient for that will be 0. Again, we do not have the term x to the power of 3, so the coefficient for that will be 0. And now we have 3 over 2 is the coefficient for x squared, -4 next, and finally we have 18. The leading coefficient, can you get it? -3. And the constant term, the last term, the term which is not dependent on the variable x, which is 18. And degree, the highest power, it is 5. Okay, so these are the essential parts of a polynomial. Variable is the most obvious one. We have coefficients, leading coefficient, constant term, degree. And when we work with polynomials, a skill which is very needed is the writing polynomials in standard form. Now let's have a look at this example here. 3x plus 4x to the power of 3 minus 2 minus x to the power of 2 minus 2 to the power of 3 plus 4x -5. You can see that the terms are not arranged in the order, and we have several terms which share the same variable parts. So the first step is to find all the like terms. The like terms are terms which have the same variable. In this case, 3x and 4x both have the variable of x, so they are like terms. We will collect them together. And next we have 4x to the power of 3 and -2x to the power of 3. They're all like terms, and we will collect them together. Can you see that? I bring 3x and 4x together. 4x to the power of 3 and -2x to the power of 3 together. And we combine them to make 7x and 2x to the power of 3. And we have two remaining terms which are -x to the power of 2 and -5. And now we have all the terms. We have new terms. And now we need to arrange them in the order of decreasing powers. The first is 2 times x to the power of 3. And we'll continue the process to get the final simplified polynomial in the standard form. 2x to the power of 3 minus x to the power of 2 plus 7x minus 5. Can you see the process? I will rewind it and play it again. We collect like terms together and combine them. This is actually the simplifying process. And again, we need to rearrange the terms so that we have a nice order of decreasing powers. And now I give you a practice activity. Simplify the polynomials and determine degree, leading coefficient, constant term. Okay, I suggest pausing the video for 3 to 5 minutes to try solve this problem yourself. After you pause it, you can continue and see the answers. Okay, have you got the answer? Let's check whether your answer is correct. Px is equal to negative 2x to the power of 4 minus x to the power of 3 plus 5x squared plus 2. So the degree is 4. You can see that the highest power is 4. The leading coefficient is negative 2. The constant term is 2. For the next polynomial, when we combine the like terms together, we will get 0x to the power of 4. And we can simplify it again by eliminating the 0x to the power of 4 to get 2x to the power of 3 plus 4x. And this polynomial has the degree of 3, leading coefficient 2, and constant term 0. The last polynomial can be simplified to a very simple polynomial, x to the power of 4 minus 4. So the degree is again 4, and leading coefficient is 1, and the constant term is negative 4. Okay, do you have all the answer right? Now we will discuss about low degree polynomials. Low degree polynomials are very common, and hence they have special names. I will show you the table of names for low degree polynomials. Remember it, and because it is for the next activity, and it is very convenient to remember the names when you work with polynomials. The first, ax plus b. This polynomial has degree 1, and it is called linear. In Vietnamese, we call it tuyến tính. There's a reason for that, but we will leave it for later. ax2 plus bx plus c. This is of degree 2, and it is called the quadratic polynomial. ax3 plus bx2 plus cx plus d. The polynomial of degree 3 is called cubic, just like a cube. You know that cube is a solid of 3 dimensions. Well, that's not making any sense because the solid means having 3 dimensions already. But cubic is like a cube of 3 dimensions. So the two terms are related to each other. Degree 3 cubic. And finally, we have ax4 plus bx3 plus cx2 plus dx plus e. This polynomial is of degree 4, and we call it quartic. Please do not be confused between quadratic and quartic. Quadratic and quartic. Now let's try this activity to test whether you can remember it. Match the polynomials to their names. Here I have 5 polynomials and 4 corresponding types. Again, pause this video maybe for a minute or two and give yourself a try. Have you got the answer? Okay, let's see whether your answers are correct. The first, we can see that it has the degree of 2. That's why it is the quadratic polynomial. The second is a linear polynomial, which has the degree of 1. 2 to the power of 4 minus 3x plus 5. It is a quartic because it has degree 4. The fourth one is cubic quadratic polynomial because it has the degree of 3. You can see that although the the x to the power of 3 term is not standing in the front line, but it has the highest power, so we still look at the coefficient, look at the power 3 to decide this is a cubic polynomial. And the final one is a little bit trickier than the previous one. It is, in fact, a linear polynomial. Surprised yet? So why is that polynomial with degree 3 with x to the power of 3 terms a linear polynomial? It looks cubic, but after simplified, it is 2x in standard form. So because 2x is a linear polynomial, so the polynomial this is a linear polynomial. So please remember that always simplify before determining the degree. Remember that, because um, there are a lot of similar polynomials which have the terms of high powers can be cancelled by each other. So always simplify it before you determine the degree. And the next part of today's lesson is to learn how to add and subtract polynomials. That is very easy. All we need to do is to collect like terms of both polynomials. Do you remember like terms? The terms of same variable parts. Here we have px and qx as shown on the screen. The first task is to complete px plus qx. So we will try to collect the like terms. So it is more convenient to write it in like 2 rows with the like terms belonging to the same column, standing straight like shown on the screen. Can you see that? X to the power 3 standing in the same row as 2x to the power 3, and similar with the other terms. Now we'll collect x to the power 3 and 2x to the power 3. We have 3x to the power 3. Next we have negative x to the power of 2. Moving on, because we have only 3x, so we just keep 3x. And the constant terms are combined to get negative 16. So px plus qx is equal to 3x to the power of 3 minus x squared plus 3x and minus 16. Can you get the idea yet? Okay, move on. Let's try subtracting two polynomials. We apply the same method, but we change the plus sign into the minus sign, of course. Again, we collect like terms. X to the power of 3 minus 2x to the power of 3, and it gives negative x to the power of 3. Moving on, we have negative 3x to the power of 2. Again, 3x is alone, so we keep it untouched. Next, we have negative 5 minus negative 11. It means negative 5 plus 11, and it gives the answer is 6. So px minus qx is equal to negative x to the power of 3 minus 3x squared plus 3x plus 6. Okay, have you learned how to add and subtract polynomials? Do you think it is any tricky? Now moving on to the practice activity. Calculate px plus qx and px minus qx. Again, I suggest pausing the video for 2 to 5 minutes to give yourself a try. All right, have you got the answers? Let's see do let's see whether you have the same answer as mine. Px plus qx, px minus qx. For the item B, px plus qx gives the answer 2x to the power of 4 plus x to the power of 3 minus x minus 2x minus 4. And px minus qx gives the answer of 2 to the 2x to the power of 4 minus x to the power of 3 plus 8x minus 20. Do you have the same answers? So that is what we have learned in this lesson. Now let's have a summary on what we have been through. First, we have learned a polynomial definition and anatomy. We know what are the coefficients, leading coefficient, constant term, and degree. Also, we have learned the names for low-degree polynomials, the linear, quadratic, cubic, and quartic polynomials. And finally, we have learned how to add and subtract polynomials. The key is to collect the like terms of both polynomials. Easy, right? Okay, so that is the end of the lesson today. Thank you very much for attending the class. And for further material, please check the comments below. Okay, hope you enjoyed this. See ya.